The broadcast is now starting. All attendees are in listen-only mode.
Hello, good afternoon, everyone. My name is Anna Zylik, and I am with ICF, and we are the vendor working on behalf of the sponsors of Energize Connecticut to bring these Passive House trainings to all of you. Thanks for joining us today. We will be recording this training, and we will make this available afterwards. These trainings are no cost thanks to the sponsors of Energize Connecticut and are part of a partnership with Connecticut Passive House. A reminder that as part of this training and workforce development initiative, we are offering a 50% cost reimbursement for individuals pursuing either FIAS or fee professional accreditation. So this includes the cost of the trainings and the exam. And once you become certified, we'll work with you to process the 50% cost reimbursement. So if you have any questions on the reimbursement process, please don't hesitate to contact us. But you can move over now to the next slide, talk about the Passive House building incentives. So in addition to the no-cost educational training series and the professional accreditation reimbursements, the sponsors of Energize Connecticut also offer robust incentives for builders and developers who choose to pursue Passive House certification in multifamily projects with 5 or more units. Next slide. Yeah. Or sorry, I guess back one more slide. The Passive House incentive design for Energize Connecticut is shown on the slide and includes pre-construction incentives for feasibility studies and energy modeling and post-construction incentives for full Passive House certification. And our goal is for everyone involved in multifamily construction in the state of Connecticut to be aware of these incentives. So for anyone interested in learning more, please visit our website or contact us directly at the address on the slide. So as for questions during today's session, please feel free to use the chat function throughout, and we will pass them over to Scott. And with that, I will turn it over to today's presenter, Scott.
Thanks, Anna. Hi, everybody. It's nice to be back with you again. We're going to talk more about air sealing today. And we've done this a couple times now. Hopefully you've been able to join us for the insulation one and the previous, the part one of this air sealing workshop. This is who Stephen Winter Associates is. This is who we are, which is where we work. And I work for them and presenting this on behalf of ICF. So our learning objectives today, we're going to talk about typical materials and methods for air barriers and high performance projects. There are challenging details that we're going to identify and try to propose solutions to overcome them. We've got common approaches for air barriers and residential projects, 2 very specific ones actually today. And then we do have one kind of alternative strategy for air barrier implementation. We'll see what you think about panelized construction when it comes to some of the products that we've got to highlight. So similar to other talks, other workshops, we plan to have a 5-minute break. It's probably going to come a little after that 2:50 mark, but we'll do a 5-minute break in the middle and then sort of wrap it up probably a little early today. Just to remind everybody why we're here, trying to push for building electrification. There's a lot of incentives available, and I don't know about you all on the phone. Well, actually, let's get an idea about who you all are on the phone. If you wouldn't mind using the pollev.com address at the top of the screen to give me a little more information about who you are. And on the next slide, we're going to ask you about what you're hoping to learn about. You can also text. You can use text to 22333. the answer to the question. So, wow, so fairly split. In the past, we've had a lot of designers. And that seems to be holding true today. All right, so it looks like consultants and architects are winning right now. Got a lot of information for everybody, all different kinds of folks joining the project team. Wondering if you could also now please let me know what you're hoping to learn about. You can put the words together with an underscore so it makes a little more sense as our word jumble sort of pops up. You can use the same poll EV. Just a quick 2 or 3 words, incentives, right on. So yeah, what I was talking about earlier was I've spent pretty much the last week or so fielding questions about some of the new federal incentives from the Inflation Reduction Act that was signed, and specifically about Energy Star and Zero Energy Ready Homes. So I don't know if anybody else on the call has been dealing with that this week, but it's certainly top of mind for me. And so I hope to be able to sort of point out a little bit where the things that we're talking about today could possibly, well, all of it is going to go towards those incentives that were signed into as part of the IRA, as we're calling it these days. So yeah, continuity of air barriers, products, detailing the air barriers, fantastic. We'll talk about all of that. Creating better buildings, absolutely. All right, thank you for the responses. This is part 2 of the second workshop, air sealing for homes. So as we've discussed, and I'll just quickly note, what are the elements of a high-performing building? What are the goals of a high-performance building? Energy and cost reduction, optimizing thermal comfort, really good indoor air quality comes along for the ride, mostly when we implement these things, and of course, carbon emission reductions. Passive house is a pathway to high performance. We talk about this, I talk about this in terms of passive house as sort of putting guardrails on your high performance construction project. Sort of forces you to look at all of the aspects that go into making a high performance building high performance. So they include good thermal insulation continuity. So not just a lot of insulation or, you know, more than sort of code required insulation, but also that it is continuous and contiguous. Thermal bridge-free construction is incorporated into that strategy. Usually there's solar control on these smaller projects, single family and low-rise-y kind of projects. You want to provide some kind of shading for summer sun. Air tightness is what we're going to talk about today. And the last one, balanced mechanical ventilation. So this is what continuous insulation might look like. Here's a blower door rig. We're going to talk about that more today. This is what we use to measure air tightness in buildings. And then the balanced ventilation and heat recovery was kind of the last phase of our workshops. We'll be talking about that, workshop number 3. So common approaches to air barrier. Kind of recapping where we've been and what we talked about in the past. There's a lot of different approaches, a lot of different products. There's a lot of different ways to sort of get a good air barrier. I think we reviewed, 5 or 6 different types of products and approaches to doing it. What we see here at Stephen Winter Associates on the projects that we work on who are doing passive house or zero energy ready home, something like that, a high performance spec, that wood frame projects are usually going to use a sheathing with an integrated air barrier, i.e. zip system or armor wall. or they're going to opt to go with a self-adhered sheet membrane in the vein of like a EP Henry Blueskin product, something like that. No matter which one you choose, we want to make sure to point out that those selected installers are comfortable with the selected system, right? So even if they have done it a lot of times before as part of the process that we've seen to work best with passive houses, that training should be provided so that they understand all the proper techniques for installation, for the installation of it. There's lots of different ways to get directions and help. Sort of the best one is to consult the manufacturer's data. Zip System has a lot of great reps working throughout the country to see that the buildings that you're working on, are going to get specified and then also installed correctly. And that goes for a lot of the, if not all of the manufacturers. And there's also, you can call folks, you can call the manufacturers directly, but reading the installation system, watching the videos that are provided by the team, or sorry, by the manufacturer, it's not, doesn't have to be on the job site as you're starting to get ready to install the product. A lot of preparation can be done ahead of time. So for Zip System, like we said, we're going to have a heavy focus on Zip System, and the reason for that is because it's what we're seeing the most in our neck of the woods, that being Massachusetts, Connecticut, New York, New Jersey, Pennsylvania, all the way down to DC. And Virginia, Zip is a pretty dominant player in the market, at least on the projects that we're working on, and especially when it's wood framed. And so we've got some demo videos that we've put together showing how all of these different components of the system come together to create a fully aligned air barrier. And we did that in sort of doing a mock-up kind of, we'll call it a hut. So it's kind of a, representing a small building. You can see all the different sides here. We've got a window that is some backer rod that's stuffed in there around this window. The window is a high performance one, triple pane, I think it's triple pane, yeah, where it's installed with a clip system. That's very typical of what we see in a lot of passive construction. This is a mini blower door fan that we actually tested before we started installing all of this stuff and after. See that there's a little door here so you can get in and out, etc. It's on top of some cinder blocks representing a foundation. And so what we did was to sort of start from the bottom up, more or less, and look at how this system works together. So what you're seeing here is the Zip System's liquid flash product being used to make the connection from the above grade wall to our simulated foundation, right? So you can see this is Mike Schmidt with our office. He's applied the liquid flash and is now smoothing it out and spreading it out with the tool. We'll talk more about the specific tools there. So he wasn't happy with, the full continuity. You can see over there on the edge there, he didn't quite get it to the zip tape. And so now he, I think, is pretty happy. Yeah, pretty happy with getting a full connection. So again, that's the liquid flash product, connecting from above to below grade. Great way to do it. We sometimes see that, when trying to get tape to adhere to a masonry product, usually there is some kind of pre-prep that needs to happen. When you use this liquid flash product, there is no sort of prep. It's one and done. And so the next one we've got here is the sill flashing, I think. I want to make sure that I didn't miss one. Yeah. That was just a double click to get it to go. All right. So here's the sill flashing, and you can see the window is not there anymore. This is the rough opening, right? And so we've got a kind of a back dam deal going on here, a piece of material installed to prevent, if water were to get in along here, that it's not going to actually penetrate into the enclosure itself. And what he's going to do is use this stretch tape that Zip has, and a lot of other manufacturers have as well, to prepare the sill and connect the rough opening of the sill, or the rough opening of the to connect the jambs of the rough opening to that sill. And so he's using that same tool again to push it into place. And because of the this this sill material that we're able to use, it's got the stretchiness to be able to work into those corners. And if you were to just use sort of the regular tape, it doesn't quite have that stretchiness. So you can see he's spending the time to get it into the corners, and here's where it becomes really very helpful. You can now stretch it out in all different directions, right? You don't have to cut anything and sort of fit it in there. He's using that tool to smooth and get any fish mouths out. Really, really stretching it out. And so the point here of using this kind of material is, again, to be able to work it into the corners so that the window is going to fit in there correctly, but that you've also got a good seal. And now he's finishing it off with the roller, right? The roller is needed to really activate that that bonding agent in the tape, in the stretch tape as well, to be able to get it to adhere to the zip underneath. And so I know we're going maybe a little quick. Just want to make sure that there aren't any questions on those first two that we've seen, where we've connected the foundation to the above grade wall, and now we've just done some sill flashing. The next thing we're going to look at is the jamb. That's here. And so continuing with the window install. So now this is the regular tape. You'll notice that we started at the bottom so that we can get the right shingling effect, and all of that water is just going to shed right down. You can see now at the top he's cutting the tape so that he can fold it into the inside corner above. If he hadn't used that, the more flexible tape for the sill, he would have had to do something very similar and then infill with some other pieces. But finishing up here with the roller, right? And so you can see up at the top, because of that cut, this is able to stay extremely, it's flush as it should be along the jamb here all the way up to the end of the tape. It's also flush here. That slit, that cut, is extremely important to be able to make that happen. The reason for the stretchy flash down here, you don't really necessarily want to be making any cuts. You know, as the water is going to run down this water resistant barrier, or this air barrier, you know, it's working to do a couple different functions for the enclosure, right? It's our air barrier system. It's also the water resistive barrier. So you want to have it shed down and have it all shingled correctly, one on top of the other, so that as the water comes down, it's not penetrating into the enclosure. So we're going to look at the head now. Starting in the middle, or sorry, starting at the end, at the corner. This again is the stretchy tape. using this to be able to really get good overlap of the jam tape, stretching it up and over, and then stretching it up and over along the top there. Oh, you can see, I'll just pause it. We, Mike already has the other jam in, right? Done identically, just a mirror of what was done before. And so he's now, everywhere here has been shingled with the exception of this connection up at the top. But again, you know, he's going to finish off the installation here by rolling that and getting that seal, getting that seal just right. And so it's been worked into the corners here, just like it was on the sill. The head has been worked into the corners using the tool, and everything is now overlapping. All right, so that was the sort of rough opening of the window. What we're going to move on to now is looking at connecting the window to the air barrier. And so we've, you know, prepped the rough opening, the window has been installed, the clips are in, and now we're going to finish off the air barrier, connecting the window to the other air barrier materials. And so this is being caulked in here. We've got some backer rod that's been installed so that the caulk can set and lie in there just right. I think at the end of this, he's going to sort of tool in that caulk. But what we've seen, especially on the exterior application for these unflanged windows, right? They're just sitting in here with clips. Using caulk is pretty much what we've got to do. So now he's getting his tool. Get a little bit messy. Mike is not a professional caulk tooler. It's not the neatest job that we've seen, but those professionals out there doing this day in, day out, you're going to end up with a very nice caulked, well, a nicer looking caulk joint than that one. What we're trying to do here, though, is to get air barrier systems to all connect to each other so that they're continuous and contiguous. Without having, let me go back a little bit to show you where we started from. So there's that rough opening, right? This is a good spot to start. Without having, if we were not to sort of wrap this around to set the tape here and connect the actual jam material to the above grade wall material, that would leave open, you know, an air pathway, right? So we need to make this connection first. We need to do it at the jam, at the head, at the sill, everywhere. And the last part is to connect the actual window to that, to those flashing materials, right? Without those flashing materials, this system would be incomplete. All right, so here's what this looks like from the inside. Interior window taping. Let's take a look. And so we're showing that use of tape is being done to do this from the inside. It's one way to do it. So this is, we've got two mics that are on our field staff with our Passive House group. This is the other mic, and he's really good at these sort of like very detailed tape drill. What he's doing is getting some little pieces of tape in there into the corners, and then connecting it with, you know, just the right sized full runs of tape for the jam. It's a it's got a peel and stick. You know, usually there's a two-part system to get the backing material off of the tape. You'll see again, he's using the tool to get it nice and smoothed out. It's really very critical when working with tapes to have a tool like that. Using your hand, you know, your fingers get sticky from peeling off the backing material, and you just need another tool to sort of be able to tool it all in there. So you can see this is a little more involved. It's a little more tedious. I would describe this as sort of like a very traditional way to do a window opening from the inside for a passive house. You can also do this with caulk from the inside, which is a little more typical in what we've seen in a lot of our projects. We wanted to show both. I'll just back up to where we started. So again, you know, this is the zip system tape from the outside. We're showing that you want to make both connections, both on the outside and on the inside. This is definitely kind of a belt and suspenders approach to the window. It's just what we've seen that you need to do in order to get this, to get these window installs to work. It's one of the most critical transitions, one of the most critical penetrations in the building, especially for a multifamily building where, you know, there's a lot of windows and not necessarily, you know, there's a lot of windows relative to the exterior wall area. In a single family home, that ratio is a little bit different. But anyway, as you can see, you know, again, the clips, right? He's working, those clips do not extend sort of past the rough opening here so that the tape can seal all of this to the tape that's the exterior air barrier, right? Again, you could do this with caulk. There's backer rod in there. You might need to put another thing of backer rod in here to get this caulking if you choose to use caulk to work. But we're showing here this being done with the tape. All right, so here's sort of kind of the easiest piece, to do. Just taping those. This one are the vertical joints, right? You can see the backing on the tape comes off pretty nice. You can move at a pretty good clip. And he's going to make a cut down here. Yep. All right, so there it is. He's sort of smoothing it out, get all those fish mounts out. Last step, roll it on. We recommend sort of using that tool to get the fish mounts, to get it nice and smooth on there. And then the tool afterwards, especially if you're just starting with a taping product. And now the horizontal. Yep, cut, wrapped around, smoothed on. He's going to use the tool and now roll it out to really get it to adhere and to really make a grip to it. Last piece is the corner. And so I don't know if anybody's noticed or picked up or how familiar you are with the zip system. You can get different widths of tape. And so for the corners, we've always recommended to use the wider tape, well, especially the corners both inside and outside. You can see it's a lot easier to hit you need to get enough adhesion on both sides of that corner for this system to work. You want to give yourself a little bit of wiggle room there, a little bit of play, so that you don't have to be absolutely spot on perfect. But that's a really good thing to consider would be to use the wider rolls, to use, the regular stuff comes through, I believe, at like 3.5 inches. Mike's using, I think, a 5.5 or 6 inch wide. piece of tape right there. And you can see that it kind of really makes it go a little smoother. Keegan, did you have a question? Or Anna, are you doing questions?
Yeah, Scott, there's a question that I think pertains right to this slide. Can you hear me okay?
You can, yep.
Okay, good. Someone commented, we've seen some issues with the zip tape not sealing interior corners very well. So do you have any tips or tricks for sealing the inside corners? And have you ever used the stretch tape for that application? So I think this speaks to this slide here.
Yeah. So this one's an outside corner, but the inside corners can be tricky. I think using that tool, we call it, for shorthand, the credit card tool that we've seen Mike use, that can be really helpful, especially for the inside corners. It can push it in, you get that tape, and your first point of adhesion can be closer to the inside of the inside corner, rather than usually, what happens is, you get something stuck on the outside wall that's further away from the inside corner than you want to have happen. So using that sort of the credit card tool is what we always refer to it as. I'm sure there's a more technical term. But in terms of using the stretchy tape, yeah, I think that would be a little more forgiving. I don't know that you would get necessarily a nice, how once you stretch it, right, it gets a little wavy. You want to make sure that you're overlapping it per the specs, per what is going to require you to do. So I think it might be a little difficult to get it all stretched out once you have it in the inside corner. And I think I would hedge toward a wider roll and using that credit card thing to handle the inside corners. I don't think we have an inside corner on this demo, unfortunately. Yeah. So this one, liquid flash again. You don't have to use tape. You have the option to use liquid flash on all the seams. You can use it on the nail heads too. Overdriven nail heads, right? You don't have to use liquid flash if it's a properly driven nail head, but he's just showing again using the tool. Not happy with the depth there that he got or the amount of material that he's got, so he's going to do it, put a little more on. See over on the corner, he's got to really run that into the tape. Yep. So liquid flash can be used on the seams as well. I think you're going to spend a little bit more on the material if you're going to use the liquid flash for seams, and the tape might be a better way to go. So this one at the roof overhang. All right, so during our last couple of presentations, we've talked about this roof to wall intersection. This is a great still image of showing why we've spent so much time talking about the roof to wall intersection. As you can see here, this joint right here, yeah, that's a very easy, joint to fill, especially with this liquid flash product. I would say you could even do, it turns into an inside corner application, but you could use tape to do it as well. The problem is, as you go around, if you haven't done this, haven't really thought this through, and you have your outlooker trusses coming through your air barrier, which is pretty common if you aren't keeping this eave and these outlooker trusses sort of off the building until you are ready to make this transition. This is what you're left with. And so what you're left with here is having to work around all of these little gaps and cracks. The liquid flash is a good way to go to work around. You're basically caulking those truss members through the what is your above grade wall at this point. This is working high up on the building generally, and it can get tricky to do. So now he's going to use the caulking tool to tool that in, making sure that it's spanning the bridge between those truss members and the zip wall. All right, so what if we did this with tape? this is going to be even more difficult. So here you can see now we do have inside corners. Mike's started out with a small piece similar to what he did on the window. This is so that he can have a little more control to get that corner just right. And I think what he's doing is working on a larger piece to now be able to go from small piece in the corner and either go across or down. Oh, I lied. He's going to do a small corner on the other side. So when you have these small pieces, I think that is the stretchy tape. Does that look like the stretchy tape to you guys? I think it is. Yeah, so for those smaller ones, his preference is to use that stretchy tape to be able to work it in there. I can't tell if that's the stretchy stuff or I think it is the stretchy stuff. Yeah, so we'll see how this looks like. I haven't actually seen this particular one, this particular slide. I'm watching it for the first time with you guys as well. So like, for me, you know, it's in there. I think the better application here would be the liquid flash. It's going to end up with sort of a neater application. What you need to do is to roll that on as well. We didn't show that in the video. But really, you know, what we're trying to show here is like, this is a very tricky transition to make, especially with tape. If you're left with something like this, sort of an upside down inside corner, probably a liquid something caulky is going to be a better job of it, because you know, this has a lot of fish mouths in it and doesn't really, you know, look all that great. All right, so what about the wiring penetrations, that sort of stuff? This is a Rowflex gasket being installed and using for pipe penetrations. And so it's got sort of a smaller diameter hole cut in there. It's got some flexibility and give for that eventual pipe to be pushed through. There you see it. So that's been pushed through from the inside, and you know, that's one option to use. I don't know that that is necessarily a real world option. You know, usually the person putting that pipe through the air barrier, you know, is doing it, you know, before somebody has been able to get a gasket on the outside and then they push it through, especially in multifamily. In single family, I think you've got a little more control and, you know, maybe a better shot at seeing that that sequencing is done correctly. We've got some other options for penetrations, though, to show you in the next couple of slides.
Hey, Scott, there's a question on the liquid flash.
Mm-hmm.
Someone wants to know, wouldn't it be better to caulk the larger gap between the room and the wall first and then use liquid flash on top of that? And follows up with, how big of a gap can the liquid flash actually be used for?
So what was the first part of that question again, Keegan? Sorry.
Would it be better, or could you use like caulking first and then use liquid flash on top of it as a way of getting those larger penetrations, or can you just use only liquid flash for those large?
Yeah. I'm not sure what liquid flash is going to be able to cover. Our general rule of thumb is like, you know, caulking can be used, I don't know, let's say a 1/4 inch or so would be the gap. If it's bigger than a 1/4 inch, sort of a 1/4 to a 1/2 inch, it's kind of best practice would be to use a backing material so that the caulk has something to be able to adhere to and sort of span that gap, similar to what we did and showed with the rough opening. But if the question is for caulk, like, maybe you could kind of try to build it up, you know, caulk and then liquid flash on top of like a cured and dried caulk. I don't think that's not really a best practice. What would be to use a backing material, something along the lines of a backer rod. You know, it's like a neoprene, you know, just a foam gasket, is essentially what that is. So, and in terms of how big of the gap you can fill with liquid flash, I don't know. We'd have to look at what the Huber says for the specs. What we've got now is sort of a final walk around of what this looks like, what our little hut, you know, where we've ended up with, right? And so sort of detailing the different penetrations. You can see we've got an electrical wire. This one has not been sealed. I think that is just air sealing tape that we use for our preliminary like mock-up testing stuff, you know, like trying to seal stuff up temporarily. But that's the electrical wire, or that's the extension cord going in there with our temporary light inside. But you can see, you know, the zip taping here. And so, oh, here it is. Oh, never mind. Bear with me. So this is an example on the other side where this kind of monopoly framing approach has been taken, as opposed to where we were with the overhang, right? So you can see the difference between here, this overhang is, you know, on the wall, it's on the building, right? And so now we're having to do origami around the trusses to get the air barrier of the wall to adhere to now the underside of the air barrier of the ceiling, as opposed to what we've done over here, which is to just go from air barrier to air barrier, nice, neat seam. And we talked about during a lot of our previous workshops, right? But you can really see how much easier that makes everybody's life, and how much of a better job I think it really comes through in that image there. Okay, so the blower door test, we actually, you know, did a test. For those of you not familiar, this is a DG1000. It's manufactured by the Energy Conservatory, and it's a digital gauge that measures the pressure and flow across your building enclosure. And so on the left side over here, we can see that we have a pressure of -50 pascals inside the enclosure, and we had a flow at 50 pascals of 1089 CFM. So when we put a 50 pascal pressure difference on here, that was the flow. 50 pascals is equivalent to about a 20-mile-an-hour wind on like all of the sides of this enclosure, right? It's like a uniform, consistent thing, but it's trying to simulate about a 20-mile-per-hour wind. So, and you can see that that's what we tested it before we did all of this sealing, right? That was with the window in, the gasketing was in, the door, as you had saw it, as you had seen it before, was there. It wasn't necessarily weather stripped, but the blower door system actually fits into that door, so it's kind of NA. It's not counted for in either this test or the post tests, which we got down to 7 CFM of leakage. And so that's a big dramatic change in how much air leakage there is from 1,000 down to 7. You know, it's not necessarily like fair. This isn't a representative, like, you know, nobody builds a house this way with, you know, no ceiling around their joints and all of that stuff. But what it does demonstrate quite well, I think, is that, yeah, the air barrier, the sheet good is there, right? The air barrier, the window is there, the roof's there, the doors are there. What's not there is any of these accessory products connecting one piece of the air barrier to the other. without these accessory products, you've got 1,000 CFM. Once you tape it, you're down to 7. That's huge. That's huge. And what I do think is fair in terms of a comparison, this 1,000 CFM, you know, this is pretty reminiscent of, like, you know, an early 90s, late 80s kind of construction where there wasn't really an air barrier. You know, it was really just kind of structure and waterproofing that was driving the discussion as to, you know, what the enclosure should be able to handle. Air was not, you know, on anybody's radar until, you know, the early 70s. And so the advances in technology here are pretty cool, especially to somebody who works with air barriers and insulation all day long like we do. So wondering what you all see and how well the ZIP system works on job sites that you've seen, that you've been a part of. Wondering if there's any other questions too, you know, relating to ZIP in the chat. But
yeah, we're caught up on questions for now, but I'll let you know if any others come in.
cool. Not too many. I think that's not too many experts for the taping. The installation is key for sure. And so I'm seeing a lot of stuff here about installers and the guys that are doing it. You know, there's quite a bit of craftsmanship there that can be, that should be, I think, as part of the system. There's a plug there for Mike. I think one of the comments here, it's not gone too well because there's too much taping involved. And yeah, you know, it's a simple system, but you know, like anything, you've got to get the details right, which is kind of what we're trying to stress in these workshops. And what I want to move on to now is sort of how can we do a better job getting these air barrier systems to work right the first time, to everybody be on the same page from the get-go, know what the requirements are, what the expectations are. And so talking about mock-ups, both exterior wall and window mock-ups. So depending, you know, the size of the project is probably going to drive what kind of mock-up you might have here. The bare minimum in terms of mocking stuff up for a lot of passive house projects that we work on are this window to wall install. And so usually it's like the first window that gets installed, we're going to come out and test it. We're going to talk more about how we do that in a second. And that's sort of an example of a simple mock-up. But then an extensive mock-up, like the image on the right here, you know, this is a 6-sided hut. It's got 2 different air barrier systems simulating what's going to be on the building. It's got a window. They're getting ready to put on this shading device that's going to go around the window. We want to make sure that when it goes on, is not going to, you know, mess up any of the air barrier stuff. It's got flat roof going on up here. That's what he's getting. That's what he's taping. And there's also a door. You know, we did blower door testing on this, so we're testing all of this stuff at once instead of just a window, right? But depending on the size of the project, you know, it's kind of probably drive what the appetite is for mock-ups. Like I said, the exterior window, wall and window mock-up is really a very important milestone for our passive house projects. Basically, you know, to put it bluntly, where projects have not passed this window mock-up testing, the project itself has failed for the multifamily work that we worked on. And, you know, had it happen to projects that I am personally working on. It's no fun. And as we've gotten sort of more experienced with the testing and the consulting that we're doing, we are finding, these windows, the window to wall connection is just absolutely crucial for multifamily construction. So it's the connection from the window to the air barrier. It's not necessarily the window itself, right? We're not talking about the glazing to the frame of the window. That's the window manufacturer's responsibility. We find that on passive house hinge style and latch stuff, that there is some adjustment that usually needs to be made to those hinges and latches. But after that's made, pretty much all of them, perform as tested in the factory, as they should, right? Really what it is this connection to the framing adjacent to it, right? And so we're going to play a little game. I think it's after the break about, what's wrong in this picture. And, hint, it's going to be a lot of stuff, is it a continuous seal around there, right? But what we started talking about this was for mock-up, right? Practicing what this is going to look like. Is spray foam enough? Short answer is no. We want to see caulking on these high performance jobs. But the mock-up is the place to practice it, to see what it looks like on your project in that three-dimensional space. Okay, so we had talked about that zip system, which is sort of a sheet. The air barrier is put into the structural sheet good. What we're going to talk about next are sheet membranes. So there's a lot of different manufacturers that manufacture this stuff. We've got stuff from Blueskin from EP Henry. What we're going to show for this presentation. So mostly, every manufacturer has the product, right? So for this one, the primary air barrier product was the Blueskin VP 160. It's the water resistive barrier, and for this one, it's also going to be the air barrier. Yeah, water resistive air barrier says right there in the full product name. What is important to note is, yeah, you've got that primary product, and then it's all of the auxiliary materials, right? These are supplementary. Well, they're not supplementary. The contractor might think they're supplementary, and other folks on the project team might think they're supplementary, but trust me, we as the certifier, as the rater, and then Blueskin as the manufacturer knows that all of this stuff that goes along with it needs to be incorporated in order for you to be successful with a good test at the end. Here are some of these uncommon tools that installers need. You saw it, the credit card thing there. Tape application tool is a better way to say. And Proclima is a manufacturer of tapes and interior air barriers. I think we talked about them last time, but they've got a tool sort of specific for it. There's also rollers, both a counter roller or a handheld roller. Here's a handheld roller, getting that tapes and whatnot, and the sheet good to get good adhesion to the substrate. Plastic taping knifing set. A putty knife is also important. These are caulking spatulas over here in the corner. You saw Mike in the video using that to tool the caulk in, and I get a somewhat neat application of it. And then this last thing is a wet film thickness gauge. And so for any wet parts of the system, you would be able to put this tool in there, and you want to have, when it's wet, you want to be able to see that it's filling these different divots, and then you can say what the mills, how much product is on there. It's very hard to tell just by looking at it. You need to have a tool to measure what you're at. So sheet membranes that are going to go from below grade to above grade wall. Here's a detail of what that is looking at. It's called out. This is a blue skin detail. And here's, where we would install that on this particular project. It's not installed. Sequencing, again, we've talked about it before. You got to do this air barrier before you get your thermal control layer on in this particular instance. So for the above grade wall, on the left, the installer is properly overlapping these different pieces of sheet good, right? You can see it's overlapped here at the bottom from one piece to the next. And they're using a roller for full adhesion. The right image is, the whole field of the wall after the full air barrier installation has been completed. It's got proper overlaps. It's all lying very flat because it's been rolled and installed properly. And, looks good. It's fully adhered. So what are some of the rough opening stuff that you are going to need? So this is I think this is the primer. Yeah, primer. And this is sort of like option one, to use the tapes similar to what we saw with zip, working those pieces into the corner, starting from the bottom and moving your way up, rolling everything onto the substrate. Oh yeah, you can see it has been primed. It's got that aqua color. I think this is just OSB, and so priming that is extra important. They also have a liquid flashing membrane, so you can use this just like zip to go around those rough openings. Saw what that looked like before. So the windows, what does this look like from the inside? Again, you can see, this is the air barrier material. It's been wrapped around the corner and it's coming into the jamb of the window, of the rough opening of the window. Here you can see the clips, right? There's quite a bit of daylight between these two things. And in this case, caulk was then applied to this liquid air barrier. What does this look like with the sheet good? So the window tape, we're using taping now to connect the window to the air barrier. It's gonna be a little trickier, but it can be done, and if it's done well, it's gonna do just fine. Over here, we're hunting for leaks. You can see this is another example where that blue skin has been wrapped in onto the rough opening of the jamb. Flanged windows. So not a lot of flanged windows out there for the high performance windows. Again, they're the clip-in, the clip style windows. Something to note here, it's a little easier to get this installed just right. Here is a non-flanged window, right? With the blue skin. Caulking is intersecting with the air barrier of the window and the air barrier of the sheet good. Going back here, using this, you need to go on all four sides to get this air barrier to work. And if your window manufacturer is advising you not to, seal the bottom of the window to the air barrier, that's a good cue to look for a different manufacturer, right? We want something that you are going to be able to get the air seal along all four sides of the window, including the bottom. Most manufacturers have weep holes. I think you might be able to see it. Yeah, these are the weep holes of this Intis brand window. They're right here. The weep holes are for any water that's going to get into this frame. You want the frame then to be able to leak out, but the gasketing of the frame is such that the air barrier is complete up here, and there's another set of gaskets on the interior side. So long story short, these weep holes are not, they're not causing any leakage for the frame of the window. It's just allowing any water that were to get into sort of like the outer part of the frame to weep out. All right, what do mechanical penetrations look like in terms of when you're using a sheet good? And these are some of the penetrations that we see. So you can sort of do a two or three part flashing with the membrane. You know, this is going on ahead of the field of the rest of the blue skin. You could also use caulk to seal around there. And honestly, we see a lot of caulk, but also when it's a zip job, that stretchy tape works really well. Here's some other options, courtesy of 475 High Performance Supply, that you can use. You know, wire penetrations, right? Very small wire, or very small hole, big wire, come through, nice gasket. Same deal with a piping penetration. And then here is sort of a finished product, finished job. That monopoly framing, again, being shown, having a good, nice connection, and then the eaves, the rakes, the fascia, everything else goes on afterwards. So wondering what issues you guys have seen with the sheet membrane systems. Have you worked with sheet membrane systems? Be nice to know if you have or haven't. We see them sort of, you know, zip is sort of prevalent, and then these sheet good products are after. I don't think anybody's seen them. Wrinkling, planar inconsistencies. Planar, I'm not quite sure what that is referring to. The wrinkling, yeah, getting it to sort of stick just right on there. Prefer zip. Mm-hmm. Okay. Yeah, thanks for sharing. I think we had mentioned it, I guess I want to mention again that primer is extremely important to get the system to work for good adhesion. And you know, without that primer, it's usually not gonna be the best install. All right.
Before you move on, kind of related to that question, but someone asked how the zip system compares to the DuPont Thermax wall system.
Mm-hmm. I don't have a lot of experience with the Thermax system, to be honest. We showed that as an option, sort of as a commercial product that could possibly be used. And so the idea is that you know, the facing of that product is very robust and durable and is going to continue to act as an air barrier. But I think it's hard to show complete comparison between Zip and Thermax. As far as I know, you know, that air barrier of the Thermax is maybe not quite as robust to sort of stand up to the construction site, you know, before it's going to get covered with the cladding eventually. So, you know, sort of like protecting that might have a little more you know, requirements around doing that. But yeah, unfortunately don't have a ton of experience with that commercial Thermax product that we talked about last time. Got a lot of experience with like the Thermax insulation, but I don't think that's what we're talking about here. All right, so we were talking about mock-ups. The second part of like mock-ups and getting these air barriers to perform well are usually contractor trainings. And so it's important to review the project goals and implement with the whole team, right? So talking about like what the design was with the contractor, what the design intent was with the contractor, talking about the different manufacturers and the products that they're looking at using to sort of like, you know, be in compliance with the specification that was written. There's a lot of transition. There's a lot of, you know, we want to talk about all those implications and make sure that the contractors understand what our goal is. So usually what we do, you know, there's these larger projects that we're working on, usually run a sample blower door test to illustrate at least the concept of leakage to the project team. And so a lot of the project teams we've worked with, you know, have seen a blower door, they've done it before, but not everybody. And so just being able to run the blower door, go around, like if it's in a contractor's, if it's in a trailer, a job site trailer, that's fine. It's just the concept of air movement through enclosures and through building assemblies. We want to sort of like demonstrate that early on in the process so that everybody knows, like, you know, the level of detail that we're looking for to achieve, and that's going to help them, you know, choose the right product for the project, and also hopefully be a little more invested in making sure that it gets installed correctly. Yeah, we look at project site conditions, as you can see, and then we talked a lot about construction oversight, but this is a picture of us having, you know, completed a successful whole building blower door test on a 60 apartment, three-story apartment building in Pennsylvania. Really recommend having a dedicated air barrier supervisor, dedicated air barrier subcontractor, right? Like somebody who, like, it's the air barrier system, it's their job. Trying to avoid having kind of like piecemeal approach to the air barrier integrity, having one person do it, but you know, the other trades are going to interact with the air barrier, and just making sure that they understand what the overall goals are as well. So got some time here. We've come to our break. If there's any other questions, we can talk about them now. If not, I think we'll go to our break.
Yeah, nothing else in the chat right now.
All right. Why don't we come back at, that's all but 3:10. We'll come back at 3:15. All right, welcome back everybody. We're gonna play a couple rounds of what's wrong with this photo. So for this to work, we're gonna need you guys to have that poll everywhere thing ready to go. And this is just gonna be sort of free form. So make sure you link your answers with those underscores, but what do you see wrong with this image? And you're going to put your responses into the poll EV, wondering what you see wrong with this zip system image. I see a couple things off the bat, but one that is tape's not flat, ripples not flat, yep, beads. We call them fish mouths, but same thing. It's not been rolled, yeah, for sure. And also they stapled it. I don't know, you know, that's not part of the installation guidance, right? This is not how you would install that with the staples. You know, the staples are going to probably be pretty much self-sealing, but the marks left behind by the hammer tacker that was used to put those staples on there, those are not. Those are just holes through there. And then, of course, once you have the staples on the tape, it is impossible to get a good roll on there. And so this has not been rolled at all. So good job, guys. How about this next one? What do you see wrong? What do you see wrong with this image? I'm not sure that we've talked about this per se. This is a ERV duct that is going through an above grade wall. This is what the detail looks like. So wondering if you see anything that's wrong with this image in terms of air barrier. Anybody see any issues with this ERV duct going through the exterior wall? Yeah. So we haven't talked about this too much per se. It's not sealed. Yes, that's, and not sealed at the insulation. Yes, extra credit for whoever put that in. There's no collar. Yeah, I don't know. There might not be a collar. It might just be sheet metal, a sheet metal duct going through there. So some other, I see the insulation sealing also, and that was the first thing that I noticed. When we're doing passive house type construction, we want to make sure that the vapor barrier of this duct is getting sealed to the air barrier of the wall. And this has to do with condensation resistance as well, right? There's a metal duct under here that's being covered with insulation. The fibrous insulation is not a vapor barrier. That's why your flex duct comes with the foil facing on it. That is the vapor barrier. And so it's going to prevent any vapor from getting in there and condensating on the metal of the duct. This is extremely important for these ERV ducts for outside air coming into the building, right? This is going to become extremely cold, the metal that's underneath here. And so you want to make sure that not only is the actual piece of metal duct that it's, you know, going through the air barrier, you want to make sure that that is sealed so that the enclosure is air sealed. You also want to make sure that the vapor barrier of the duct is sealed to the air barrier or vapor barrier as well, so that you don't get any condensation happening on the actual metal part of the duct. So good job. Image number 3. Here we've got some spray foam and caulk. It's like attaching from the rough opening to the window itself. So what are some issues with this? gaps in the spray foam sealing. I think that said excessive foam, excess foam, yeah. Yep, spray foam has gaps. For sure. So right here, there's a gap in the spray foam, right? If you're looking at this quickly and not really going over the entire, four-sided piece of the window, you're going to miss this. What I also see is that the caulk and the spray foam are not necessarily, especially in this one, not necessarily joining up, right? There's probably some air pathways there, definitely some air pathways up at the top. The caulk has been, going over top of the clip as it should, but this spray foam is not going to work for if you're trying to get to passive house. You can't use spray foam to seal a window to the rough opening. You have to use backer rotted caulk. That's just all there is to it. So I think you picked up on that. How about this one? This is a throwback to the previous workshops. Wondering how many of you have been around and doing it with us for a couple of workshops now. Wondering what you see wrong in this image of, it's like mineral wool insulation. Yep, poor insulation with gaps. Insulation has voids. It's not a good insulation install. It's a grade, that's a grade 3 for sure. Grade 1 being the best, grade 3 being the worst. There's no insulation here, there's no insulation here. So voids, gaps. This stuff over here is all compressed. I would call this stuffed in, thrown in insulation. It's not blown in, it's been thrown in. All right, what about these images? So back to the sort of sheet applied air barrier. What's wrong with these this install? It's wrinkly, it's poor adhesion, there's air bubbles in it, the overlap does not fit. Seams in the membrane. I don't know if I picked up on that. Oh, yeah. So this one, when it comes down, well, no, it might not overlap there. That looks like it's been torn. So wrinkly overlap, yeah. So this one has not been, it's not adhering to the substrate, right? Like it's just not. And so the overlap of this other one, you can see, I think that's a nail. It's sort of been tacked on there. So I think the installer here is not understanding what the manufacturer's directions are, in that you don't nail and tack it on there like Tyvek. It's not Tyvek. And then over here we see, wrinkles and stuff. This is the worst of it, obviously. That's not going to work. You can see these fish mouths, these wrinkles going into the next, I think that's the next sheet there. And so that right there, not a complete air barrier. And trying to get this roof to have a transition to the roof, it's impossible using, I think, this material at this stage of construction. I'm not quite sure how you would get this to work. I guess maybe they're thinking they're going to overlap, like run it up and over the eave, but that's going to be a disaster. All right, how about this one? This is some blue skin again, sort of a pretty traditional looking detail. Yep, not sealed at the foundation to the wall. You guys are picking up, somebody picked up on the insulation itself. Yeah, so here's the insulation. In terms of insulation continuity to what we would assume would be insulation up here on the above grade wall, there isn't none, right? That's a big gap, thermal bridge. In terms of the air barrier, this is the air barrier, and whether it was meant to be stuck to the foundation itself or whether there was supposed to be another like waterproofing membrane that's coming up from like the underslab, either way, it's not working. It's not been done correctly. That's not sealed by any stretch of the imagination. The only thing that might save this is if there was a gasket between the mud sill and the foundation wall. You know, that might save it. You might be okay there. Image 7, what's wrong here with these? Look to be wire and conduit penetrations. Yeah, the conduits are not sealed, right? No sealing at the wiring, yeah. So for me, this one is an example of the accessories not being used. And you know, this is the result that you sort of get. I think that's another wire, or maybe it's a tear. Yeah, so like you just can't poke the wires or the conduits through the regular air barrier material, right? It's not meant to handle the penetrations. You need something else. And so if you had prepared for it, you could have done, you know, some kind of like the patching thing that we've seen where, you know, it's meant to sort of pull through that gasket. At this stage of the game, though, it's probably going to be like caulk, a very messy caulk job to try to get this adhered using the liquid membrane that is approved by the manufacturer. How about this one? What we've got here is a non-flanged window that's been taped to the air barrier, the zip air barrier. So flat window. It's not sealed at the window frame, that's right. It's, yeah, irregular taping. Oh, the headlamp's wrong? Yeah, I guess you're right. The head should be overlapping the jamb. I hadn't picked up on that. Nice job. So yeah, full disclosure, this was one of my very first passive house projects that I was the field verifier on. And I think that's my hand. Anyway, the contractor had tried to use just tape to make the seal between this clipped in passive house window and trying to sort of, you know, flash it to the air barrier. And as you can see, it was a complete fail. You can't use this zip system, this regular tape, to be able to go from the frame of a window to the air barrier. At the very least, you've got to prep the opening ahead of time. Best case, you know, we want to see caulk here with the backer joint. You know, this is probably also an example to use that window thermal buck that we talked about a couple of workshops ago. because you know, this is held out so far because there's going to be some exterior insulation that's put on here. It's just not really been detailed all that well, and then the installation is not good, right? So this is not it's not a water resistive barrier. It's, you know, water's going to leak in here, and then let alone air leakage. When we tested it, it was through the roof. This is the last image to play what's wrong with this image. What do you guys see? Mm-hmm. Yep. Probably not been rolled. I think that's a nail that's between the zips, you know, the board and the tape itself. This seam is really bad. I think even, you know, no credit card tool was used to put this stuff on, and not a lot of care was used to put it on. It looks pretty bad. Wrinkles over here, and then not quite sure if this is to the rough opening or to the window frame itself or not. It looks like it might be. And so again, not a recommended install to use, to go, you know, zip tape to a flanged window, yes. Zip tape to an unflanged window, probably not. So we had said we were going to talk about some different kinds of techniques to do an air barrier, some, you know, newer stuff. We'll talk about panelized construction for a bit. We've got some photos in a little bit. So we've seen panelized construction, seen it quite a bit. Still need to deal with sealing one panel to the other, those joints, right, as they come out to the site. But the exact tolerances of a factory-built panel versus the in-field conditions, you know, trying to make all of that work and make it fit can be challenging. But some of the benefits that we see and some of the photos that we've got here, it is a controlled environment. You get usually a little more QC. It could potentially go up a little faster, and then of course, the weather-related damages to the materials and construction materials usually is a pretty good benefit, and then there's less waste, typically. So here's a panel that we've seen. This is this Armor Wall product. So that is not the Thermax product that we had a question about earlier, but it's also not the Zip. It's a little closer to Zip than Thermax, I would say. So the air barrier is applied to control environment, so it's not going to see the elements, you know, these kind of derates for the element. Dust is something we haven't talked about, but you know, dust when trying to get zip tape to stick to a surface is a concern. You got to have a clean surface to be able to zip it to, and then temperatures too. As we usually in the winter, you know, move into the winter months, that's where those low temperatures can really mess with your sealants a little bit. So yeah, the Armor Wall was the material being used here, temperature controlled, you know, very, very different from a regular site built process. These dimensions can sometimes be a little more exact and precise. You can certainly get a better look at, you know, all of the different areas that needed to be sealed and how well they were sealed, as opposed to a site-built construction that you are maybe, you know, 2 or 3 stories in the air trying to look at it from the ground level or on a ladder. you know, you're lucky if you have scaffolding, but that's not usually the case on wood frame construction. Yeah, and so here again, being able to like really put eyes on what this stuff looks like. I don't think it's the best and neatest, cleanest application of the air barrier, but it is meeting, you know, it's definitely thick enough, and you know, they're overlapping the seam by 1.5 inches in either direction, 3 inches total, which is what this manufacturer was looking for. So arriving on site, you got to find a place to store the panels, right? A lot of times they're going to need to be protected from the elements. Enough space on the site to be able to store it. Here's some example of a panelized zip system, right? So you can see the corners have not been done, and I think all of this was done in the factory. Yeah, so the inside corner here where this panel meets up with the next has not been done. That needs to be done in the field. And then of course the floor to floor connections have not been done. So this piece is going to be infilled in the field, and then having to have zip tape applied, right? So you know, there's some savings here having done the panelized in the factory. This is what it looked like at the end. Again, that corner has not been done yet. So, you know, saving a little bit. Again, the monopoly framing here, making all these connections really easy on everybody. Yeah, and for sure, those joints, those connections from the foundation to the wall and the wall to the roof have to be done. So, yeah, I think we're getting to the end here. Wondering if anybody has any final thoughts or takeaways. If you do, please pop them into the poll. Also got plenty of time for questions and any final discussion. Sure.
Yeah, well, you take some of those. There's kind of a two-part question here. Do air bubbles in the self-adhered membranes really cause air leaks? And could you cover the penetration area with a flexible membrane and then poke through for each penetration? Those might be two separate questions.
I think that's a two-parter.
Yeah.
So the wrinkles and the bubbles and everything, as long as they're contained within sort of the field of either the zip tape, of either the tape or the sheet member of the sheet good, no, it's not going to cause an air leak. What happens a lot of times though is that when it's really wrinkly, you have the ability to connect like the joint of the plywood behind the sheet product to the exterior, right? That wrinkle like runs the whole way to the edge of the sheet good. That's where the problems really start to come into play. And so usually when you've got a lot of wrinkling, you know, you are going to have a D-rate to how well that's going to perform under testing conditions, which is why we sort of really harp on avoiding those. And the same is true for the zip tape. You know, those wrinkles are going to connect the seam. You know, you don't have tape on a zip system unless there's a joint or, you know, some sort of transition piece from one piece of material to the other. And so, you know, there's a joint there. The reason the tape is there is to cover the joint. And if you are not fully getting that fish mouth, you know, that wrinkle to get nice and flat on the piece of zip, it is going to be it's not going to perform. It's no longer a single system. Now it's just some components to, you know, that are next to each other. And in terms of stuff coming through the membrane, wire penetrations and whatnot, yeah, as long as it's flexible and it's going to seal down onto it, right? So you've got to start with a smaller opening and then push the larger pipe or larger wire through it. Yeah, that'll seal. You know, same concept we've been using for years on vent pipes through a roof, right? That's a gasket. It's the same concept, and just have to have it sized correctly. All right, so I don't think we had anybody weigh in on any final thoughts, but this was part 2 of air sealing for homes. We talked a little bit about insulation, not a bunch, but the next workshop is all about high performance ventilation, and it's sort of the third thing to sort of like complete the passive house story. So we talked about continuous insulation, talked about air sealing, and then got to talk about high performance ventilation when you talk about passive house. So that'll be the next workshop.
Hey, Scott, before we wrap fully up, there were a couple other questions, quick ones, I think. What's the expected life life expectancy of these tapes and sheet membranes that we've talked about today?
Ooh, that's a good question. I don't know. I don't know what the kind of warranties the manufacturers have for them, and I would expect, we're expecting a lifetime performance on that. I think usually in the industry, a lifetime is 50-ish years, but we would need to do a little more research to say for sure.
Cool. And then Anna, if you're still on, there were a couple questions just around the recording of today's presentation, and also folks looking to get their CEUs. If you want to do that summary again.
Yeah, sure. I'm going to send out a link to the recording once we have it posted on the Connecticut Passive House website. Part 1 is already posted up there right now, and anyone that attended that first part should have gotten an email. And also, yes, if anyone wishes to receive AIA or BPI credit, I'll be sending out a survey in a separate email to people that attended both sessions. You have to have attended both of these sessions to get the credit. So look out for that survey, and we'll collect your info to send the CEUs out.
Great, thanks. Yeah, Scott, I know you mentioned a little bit, but there's some couple questions on the ventilation workshop that's coming up next, or the webinar coming up next. Do you want to just give a little teaser as to some of the content you'll cover in that?
Yeah, so we're really talking about the different types of ventilation strategies that we see on typical builds. So like supply only, exhaust only, and balanced. And for passive house, we pretty much only talk about balanced ventilation. So we'll talk about ERVs and HRVs, and we'll talk about doing balanced ventilation, maybe not necessarily doing energy recovery, right? Like that's kind of like a poor man's balance system. It's kind of how we refer to it. But yeah, a lot about ERVs, HRVs, how to size it, best practices for design and installation, construction, all that good stuff.
Great. Great. Well, yeah, looking forward to that. Thanks, Scott, today, and thanks, Anna. And thanks to the sponsors of Energize Connecticut for hosting these and putting these trainings on. So.
All right. Thanks, everybody.
Thank you.
All right. Take care.
Bye.